In this video, I'm going to show you guys how we're going to look at doing Quiz B. All right, so I've gone ahead and opened up Quiz B for you. And in this example, it talks about a fast food restaurant has just leased a new freezer and fryer for 3 years. It gives you some details about the service contract for the freezer in terms of that if they come out to do a repair, all right, they're going to charge you $35 for each time. And then $125 is the flat fee, so that doesn't change. So just you pay the $125, and then every time they come out to repair it, you got to pay $35. All right, now they've given us some data about how likely it is for them to have to come out and do a repair, which is good, right? That gives us kind of this probability model. All right, so we have this random variable, which is the number of repairs. I'm going to go ahead and write that. So I'm going to let x equal the number of repairs needed. And again, as we talked about before, this is actually going to be discrete because it gives us the options of no repairs, 1 repair, 2 repairs, or 3 repairs. None of the freezers have required more than 3 repairs in this 3-year service contract. All right, so in this idea that we have this random variable x, it wants us to find the expected number of repairs for each year. All right, so we've done this before by hand where we would do the 0 repairs times 0.8 plus 1 repair times 11%, so 0.11, and so on and so forth. But I'm going to show you, I know you guys are really excited, I'm going to show you we can actually do this in the calculator. So I'm going to do a new document. I'm going to add list and spreadsheet, and I'm going to type in, this is going to be my repairs. So my repairs. And then I'm going to do my number of repairs is 0, 1, 2, or 3. And then for my probability, I'm going to write just prob for probability. My probability of these repairs is going to be, I believe it was 81%. Let me just confirm. No, 80%, so 0.8. Then 1 repair is 11%, so 0.11. Then it says 2 repairs is 5%, so 0.05. And then the probability of them coming out 3 times in a year is 0.04, so 4%. Okay? So you've got those in there, and I'm going to do doc, insert a calculator page, and I'm going to find, as we've done before, go to menu, find stats, stat calculations, just one variable statistics. Again, we have one random variable right now, which is the number of repairs. All right, so this should look all familiar to you. Our X sub 1 list is repairs, but this time, usually we just hit OK, right? In the first semester, we just hit OK and we moved on. But this time, because it gives us the percentages for each of those number of repairs, when we go to frequency list, so click the arrow for frequency list and hit prob, so probability. All right, then when you hit OK, it's going to give you, remember again, scroll up, the expected value. In this case, it's X bar. We would never write X or Y bar because this is a model, right? This is just what we think is going to happen. So we're going to use mu, or you could use E of X for the expected value. And that expected value is 0.33. So when I write my answer here, my expected value for the number of repairs, so mu, or the expected value for the number of repairs is 0.33 repairs. So I know you're very excited because you probably saw in that kind of output on the calculator that when it's asked us to find the standard deviation for the number of repairs, you don't have to do it by hand. If you go here to the calculator, you can see that our sigma, notice SX, we're not using that one, that's all that we used last semester. We will use that again, but the SX is not the one we're using this time. Now it's sigma, right, the symbol there for standard deviation, because again, this is a model, so it's 0.749. All right, so that's going to be our standard deviation. So you can write sigma, or standard deviation of X is 0.749 repairs. All right, so it gives you an idea for the spread for that one. All right. Now, for the mean and standard deviation of the restaurant's annual expense. So now we need to bring in the service contract that it said up here. We have $125, which is our flat fee, plus $35 for any service charge. Okay, so I'm going to go ahead and write our mean for the expected expense is going to be our $125 plus, and this is where I'm going to multiply my $35 times the number of repairs. Well, how many repairs do we expect per year? It says annual expense, so each year. So each year we're going to expect 0.33 repairs. So that's what I'm going to write 0.33 in there. So you use your calculator to multiply all of that, and you get that to be $136.55. So that is the expected annual expense, or the average or mean annual expense for this service contract. All right, now for the standard deviation, all right, the standard deviation, remember we've always dealt with variances. So I'm going to start with finding the variance over here of that. So to find the variance, if you go ahead back to your calculator and you scroll all the way down to the bottom here, that last number is actually the variance. It says SSX. That means the sum of the squares of x. All right, so you can see the work that they did. They took the value, subtracted it from the mean, and squared it. So that's our variance, which is 0.5611, which is great. So they've already done the variance for us. So I need 0.5611, and that's going to multiply by my constant, which again, the 125 is not going to factor into this, because if you think back to a long time ago, I believe it was chapter 6, whenever you add a constant to all of your data values, the measures of spread do not change, right? If I have my values go from 0 to 60, and then I add 50 to all the values, the measures of spread won't change, right? The measures of center will, but not the measures of spread. So the 125 is not going to be in this calculation. But the 35, because that's multiplying, right? Whenever we multiply by a constant, the measures of center and the measures of spread change. So I need to multiply by that 35. But again, because it's variance, I'm going to multiply by 35 squared. All right, so I have 35 squared times that 0.5611. So 35 squared times 0.5611. And that's going to give me my variance for this annual contract. All right, but I want just dollars, not square dollars, so I need to take the square root of that value, which is going to be $26.22. All right, so that's going to be our standard deviation over here. So standard deviation, I know this is still number 3, sorry about that, still number 3, is $26.22. Still number 3, $26.22. So let you guys copy all that down. Make sure you have this, because I'm going to clear it here in a second, and we're going to go on into 4, 5, 6, and 7. So again, we have the expected number of repairs each year is 0.33 repairs. So we're not even expecting a total of 1 repair each year. Then we have the standard deviation for the number of repairs each year is about 0.749 repairs. And then for our contract, so how much do we expect to pay for this contract each year? We expect to pay $136.55, but then we have a standard deviation of about $26. So we're looking at a range. You can look at that different value, give you a measure of spread for that $26.22. So you have that written down. I'm going to go ahead and clear that, and I'm going to continue down here with 4, 5, 6, and 7. So how many times should the restaurant expect to have to get this freezer repaired over the 3-year term of the lease, okay? So that means I need the expected value for the first year, plus the second year, and then the third year. So again, we're looking at 3 distinct random variables, all right? If we assume that they're independent, we can just add the expected number of repairs. All right, so we're going to be talking a little bit more about that in number 5, about maybe we can't make that assumption, but we're going to just add 0.33 plus 0.33 plus 0.33. Or we could have done 3 times 0.33, because repeated addition is just multiplication. So we get a total of 0.99 repairs, or about 1 repair over the 3-year term of the lease. So that's what we're expecting. We're expecting our freezer to be repaired at least once over the 3-year term of the lease. All right, so now to the standard deviation. So again, we're going to deal with variances. So I want the variance of the first one plus the second one plus the third one. We have to assume that these are independent events, right? That each one is independent. So whether I need to get it repaired in year 1, does that affect whether I need to get it repaired in year 2 or year 3? Now you may be thinking, well, I mean, if you have to get it repaired in year 1, aren't you more likely to have to get it repaired in year 2? You're probably right. These probably are not independent. So that's why it says, on what assumption does your calculation rest? Do you think it's reasonable? It may not be reasonable, but we're going to go ahead and show you that if they are independent, if we assume there's no association between the years, then we would just add the variance. All right, so again, our variance was 0.5611. So I'm just going to add 0.5611 3 times here. Again, that would be the variance, but I don't want that. I want the standard deviation. So that's about 1.683. And I want the square root of that for the standard deviation of all of these, which is going to be about 1.297. Again, if your numbers are a little bit off, not that big a deal. It's about 1.297 repairs. Okay? All right, so key thing there is we're assuming independence between each of these years for the number of repairs needed. All right, the last two, 6 and 7. So now they give us some numbers about the fryer, right? In the beginning of the example, well, not only did we lease, or the restaurant lease a new freezer, but they also leased a new fryer. So it says the mean annual cost of $140 for that service contract plus a standard deviation of $40. All right, so what's the expected value for both? Well, if you go back up to number 3, we found the expected value for the freezer was $136.55. And it wants us to figure out the total between these two. So the expected value for the fryer is $140. So when I add those together, I will get the expected value for the total. So that's going to be, what, $276.55. So that's my expected value for the total of the freezer and the fryer and their contracts. But then it says the standard deviation. Now again, we're going to work with variances. So the standard deviation that we found in number 3 was $26.22. All right, so I'm just going to write it in red above it. So I have, let me to the side. So $26.22 for the freezer, and the fryer I'm going to put over here, which is 40. But that's standard deviation. We always want to deal with variances, so that's why I'm squaring them. So I'm going to add 26.22 squared plus 40 squared. So let's see, $26.22 squared plus $40 squared. Again, this is the variance. This 2,287.49, that's the variance for the sum of these two contracts. But I don't want that. I want the standard deviation. So I'm going to hit the square root of that, which is going to be $47.83. All right, so that's the standard deviation for the sum of these two contracts, $47.83. I'm going to write that here. The standard deviation is $47.83. All right, now the last question. Which service contract should the restaurant expect to cost more each year? Well, the fryer, right? The fryer costs $140. Right, if I just look at my work above, so the fryer, we're expecting $140. The freezer, we found $136.55. $136.55. So it looks like the fryer is going to cost more, and you can subtract to find that difference of how much more, which is going to be less than $4, $3.45. Okay? And then my favorite one, which again, this always confuses students, but we're doing the difference of these two contracts. So you think, oh, I should do the subtraction of the variances to find the standard deviation. But again, we're subtracting, but you need to be thinking, what do we do with the variances? We add the variances. So variances add. So my answer to the previous one of $47.83 is also going to be the standard deviation for number 7, $47.83. Don't do the same work over again. It's the same. All right, so that's quiz B.